Hello and welcome to another tutorial. This time we create a UI system and we are going to be using a technique that is called immediate mode UI. And in order to understand how that works, I think we need to draw a picture. So let's say in Paint right here, if we have a UI element, which could be just a rectangle, this rectangle can have buttons and all of these buttons can have different states. And these different states can be hot, active, and of course inactive. Well, what does hot mean? Hot means the mouse is currently hovering over our UI element and therefore usually what happens, it lightens up or it becomes brighter. That is the first state. And then the active state is a state in which the mouse is on top of the button again, like this, but we are actually clicking as well. So we have clicked on top of that element and we can hold down the mouse and move off the button, yet the button is still being drawn or shown as active. That's usually what you do in games when you move off the button and then the last second you come back and then you release. We clicked on the button and we are currently holding down the mouse. Clicked plus holding. And I suppose over here we can hovering. And then there's the last thing, this is inactive, which should be quite easy. It is none of the two states. So in order to model this, what we need to do is we need to keep track of the hot and the active UI element. So let's say in our UI state, which we have, let's call this UI ID, that is hot, and we have a UI ID that is active, and you know the other stuff. And we need to keep track of this every frame, meaning that when we draw it, when we draw the UI, this frame, and the mouse is on top of one of these elements, we need to set that element as being hot. And then the next frame, we look at the element that was hot last frame and check, is the mouse still hovering over this? Yes. Have we clicked this frame? Yes. Then we set that to active. And when it is active, we need to check if we are actually releasing the mouse and we are still inside the rectangle of this UI element. Then we fire what we call our callback. So in immediate mode UI, if you want to do a simple button, you start off with bool do button, right? And what do you do in this function? You check if is active, some sort of ID. We need to uniquely identify this button to know that this button is currently active. Then we need to check if the key was to release this frame, which would be from the input. And that would be the key, of course, left mouse that we don't have yet, right? The left mouse key needs to release, but something else needs to happen as well. We need to check if we are, and I like to call these functions, I know them already, point in rect. Well, what do we have? We have the point, that would be the mouse position, and the rectangle would be the rectangle of the button. Are we inside the rectangle of the button? Yes, then we set a result to true. And that result would be something we define up here, bool result is false. And down here, of course, we return that result. And so somewhere in the code, we could go, if this was implemented, and do if do button, then do some code. And that would be the so-called callback. Quite simple. That's immediate mode UI. And what that means is if we have some other branch, if, you know, option A, and then we do a button like in some location, right, like this, we could also have an else check here that says, well, okay, I don't want to do a button in option B, or only if I have option A. Well, that is immediate mode, right? We forget about the fast frame. We don't know any UI elements this frame. We start off with two button calls and that creates our so-called tree, our UI element tree. And then we have conditions and sometimes we draw and sometimes we don't. The downside of this is if we draw this and we hover over a button, we lag one frame behind. We do not know that when we are over this button, this frame, that we're actually over it. We will know that next frame. But so far I have not had any problems with that. But we are not done yet, right? We also need to check else if is hot. Are we hot? We need to check, well, have we key pressed this frame? Have we pressed our key, this frame? The key left mouse. Then of course we want to do something like set active. You know, this ID. And then what we always check, and that's the function that we defined above again, the point in rect of the mouse position with the rectangle of the UI element. Then we want to set this as hot ID. And now you're wondering if this entire thing, background, is a UI element and this button is a UI element. Both of those UI elements will have an ID. Which one will be hot? And this is where I introduce what is called layers. So first, in order to do that, we need to create a struct UI element, and that UI element has a UI ID, a rect or vec2, we do rectangle. Since we want to draw textures, we also want to have a asset type ID, and for that we definitely need to include the assets.h file so it knows about this. And then this UI ID, this is where the layer comes in. I like to create a struct UI ID. Actually, that's not struct like that. And in this UI ID, we have a UN32T actual ID. That's a number. And then we have another UN32T, which would be a layer. And then in this UI ID, what we can do, we could say, okay, this is layer 0 and all of these buttons are layer 1. And then when we set the ID to hot, because we are inside the rectangle of the button, we check, is the currently set hot element layer greater than our incoming UI ID layer? Yes, then we do not touch this, then we don't change. And since I have programmed this already, I know that when we want to animate buttons, I have created these two pictures for us to use, like the background as a big button or big just static image, and a button here that is animated. It has a normal state, a hovering state, and a pressed state. But this is an animated sprite, just like our font atlas is an animated sprite with an animation index. And so that I know, we will need a UN32T animation EDX so that we can animate our UI. And then we also want to have text on the buttons because we already have labels. And so I thought I would add that too. Now in the UI state, this is where the interesting stuff happens. This is where we store the hot and active elements. We want to have a UI ID that is active, and we have a UI ID that is hot, and we want to have a UI ID that is hot the last frame. And I guess I call this hot this frame to make sure it's consistent. In order to understand why we need the last frame, we need to look at how buttons are being generated in the UI tree. Let's say we are starting to draw and we begin with this big background. The way we programmed this, we are checking if it is hot first before we are setting this to hot. Meaning we will never set something to, we will never get a true out of is hot since we are setting this afterwards. And we need to set this afterwards because if we draw this UI element and know the mouse is inside, then any click we do, this frame will also interact with this UI element, even if there's buttons coming after this that will most likely catch, right? Catch the click. And so we need to check if it was hot last frame. So we went through the entire tree once and we ended up with one UI element on top that is actually hot, you know, where the mouse is hovering over currently. And then we know, oh, this is the hot UI element. So that's why we need the last frame. And we use this frame to keep track of the currently hot element, you know, keeping the one frame lag in mind. So yeah, back in UI.h, I think it would be a good idea to also create a const expression, max UI elements. We set that to 100 and let's just copy that, call that UI element count, then UI elements, and that's a UI element, like so. Okay, I think the next big thing we should do is go into UI.cpp and create a UI element when we call the do button. And for that, we create a UI element pointer e and set that to 0. And then we do a check if, and I suppose if we do the button, we need to have the UI state pointer UI. Then we check if UI element count is less than max UI elements. Then we set the, let's call this, yeah, let's keep this as E. E is the address of UI elements on UI element count plus. And what I like to do always is to set the value of E to nothing, basically initializing to 0. Initialize to 0. And then we take that UI element and set the asset ID to the asset type ID that we do not supply yet, but I think we can do that right now. And we also need input, right? And use the input state pointer first, and then the asset type ID, we need the E rect, set that as the rectangle. We need E ID. Let me double check how I implemented ID. The first thing is the IDs. The second thing is the layer. And so we need to supply some sort of ID. and some sort of layer. And what I like to do, I forgot about the layer in the UI state. I keep track of a uint32t global layer. This global layer starts out as 0, the UI global layer. And what we can do from outside is we can just increase that and make sure that stuff is on top. Let me supply the uint32t ID next. And then the rectangle rect. And if I remember, we also need a char pointer. Okay, let's see. We should have all of those. Then e-text, of course, is text. All right, now we can implement the isActive and isHot and setHot functions. Actually, I have done this before, and it's much better if I expose this function, which would be a bool isHot. It takes in the UI state and an ID, which would be a uint32t ID. And then it just returns if UI hot last frame dot ID is greater than 0. As a rule of thumb for this UI system that I use myself, I keep IDs as greater than 0. It can be any value, but it needs to be greater than 0. And UI hot last frame dot ID needs to be the same as ID. This is for isHot, and then we have a bool isActive, takes in UI state, UI, and uint32t ID again, and then it just returns UI active dot ID greater than 0, of course, and UI active.id is the same as ID. And then these two functions can be exposed and called from the game, which is very helpful. I've been using these a lot in the game, and so I thought it'd be nice if they were exposed. Now we have isHot and isActive, and the other functions should be internal functions. Internal void setHot. Let's start with that. That takes in the UI state, UI. And this time it takes in a UI ID. setHot is something we can only do if we currently have no active UI element. If you notice, when I click on this button, I can hover over quit and release, but it doesn't do anything. It doesn't even light up. When we are currently interacting with a UI element, we cannot set anything else to active. That's how it works. And so the first thing we need to check if UI active.id is greater than 0. If that is not the case, let's brace this. And this is where the layer comes in. The UI, let's call this UI ID. UI ID. And the UI ID dot layer needs to be greater or equals to the UI hot this frame, not last frame, but this frame dot layer. We can only set something hot that is in the same layer or above the current layer. I think the same layer makes sense. You could argue if not. It always depends, right? And then of course we set UI hot this frame to UI ID. That's the first one. And then we do internal void set active UI state UI. And of course that takes in the UI ID. And for this we don't need a check. We just set the active to the UI ID. And one last function is the set inactive function. The way I like to do this is I just want to call set inactive specifically. Every time a different type of button is active, there is a different condition when it's done doing stuff. Like for example, when you release on a button, this is when you set that button to inactive again. But when you have like a following button and you're like releasing, that's when you would set that following button to inactive. And there might be some different code paths that you hit. So I like to do the UI active to nothing thing here. Now back to the button. What we can now do is check if that is actually active. And that just takes in a UI element or the UI state and the ID. And that would be the eID.id. Or we could just, you know, take the supplied ID as well. And then isHot is the same thing. We just put the UI in front and put the ID here. And for setActive, we need UI and this time a UI ID. That would be the eID. And for setHot, it's the same thing. We supply the UI and the eID. If you remember, we had these buttons light up and change their state or the display based on what they do. And so we need to control the animation index. And at this point, it's very easy. When we create a new element and that is active, we set the animation index to 2. And when it's hot, we set the animation index to 1. This is what's happening internally. We just draw the different pictures. Next thing that we need to implement for this button is the text. And since we already have a draw text function, it's very simple. What I like to do is create a vec2 text position. And if you notice, the text moves down together with when I'm holding it together with the button. It gives this nice effect of depth. I achieve that by taking the text position and assigning that as the rect text.position for now. And then adding a little offset, nothing on X, but about 9 pixels on Y. And then down here, after we are done checking the button over here, when we are active, we want to set the text position.y. We increase that by, I tested that out, 3 pixels. And so that makes the text move down, even though these two things are just disconnected from each other. And down here, we just check if we have a text. Then I want to position that text where the button is, but in the middle. And in order to know where to position the text in the middle, we need to know how large the button is. We know that. And we need to know how large the text is that we are going to display. And for that, I would like to create what is called a getTextWidth function. TextWidth would be something like getTextWidth, and that just takes in the text. And then we do text position.x plus equals, we take the rect.size.x, remove the text width from it and divide that by 2. That would be the center comment here. And then after that, we just do text. Pick in the UI, the text position and the text. Boom, that easy. Now we need to implement that function, and I would just put that below the set inactive calls, like internal float get text width takes in a char pointer to a text. That would be the float result is 0.0f. The reason why this is float is because a vector needs floats and I don't want to convert. You can also use ints here. It does not matter much. We keep track of the float highest text width, set that to 0 or below the result. And we only do stuff, of course, if we have text. And then we do the while loop while char c is the value of text plus. We check if c is the same as \n. Now, when we have line breaks, we need to reset our width and check if the width that we calculated is bigger than the biggest width, then we use that, right? We want to like create a box. So we check if highest text width is less than result. Then we set the highest, and I see that I have a mistake here. Highest, change those real quick. We set that to result and then we continue result here. If that is not the case, we just increase the results length by 15.5. And why 15 pixels? In assets.cpp, we create the font atlas and we scale that to a size of 30 pixels height and 15 pixels width. And so I just took that number. This will change later when we are actually scaling properly to world size and stuff. But right now it's not really important. And after we are done calculating the highest text width, we check if result is less than highest text width. Then we set the result to the highest text width and below return the result. I just removed the bottom part here, the demonstration of the do button. What is left now is to implement the left mouse keys. We don't have left mouse key detection in our input layer. And we don't have a function to check if a point is inside a rectangle. And I think that's the one we should do next. That is in mymath.h. And I would love to put this below the rectangle over here. It's a bool point in rect. It takes a vec2 point and a rectangle. In order to know if something is inside a rectangle, it needs to be, if this is a rectangle, the mouse needs to be past this barrier and inside the top and height things, but it also needs to be on the left side of that barrier. So these are basically 4 if checks. We return if point.x is greater than rect.position.x and point.x is less than rect.position.x plus rect.size.x, and then point.y needs to be greater than rect.position.y and point.y needs to be less than rect.position.y plus rect.size.y. And that's it. Now we should have a point in rect function. Yes, we do. And we don't have a mouse position. And for that, I want to store this in the input state. So in the input state, I want to have a vec2 mouse position and a vec2 mouse click position. And while we are doing this, we can also use a vec2 previous mouse position. Then I also want to do some other stuff. I want to change the key codes to be key underscore. So remove the prefix and then key A, D, S, W. And then we also have the key left mouse and then the key middle mouse, middle, and the key right mouse. This is everything we need to change in the input layer. Now what we can do is change, if we actually press the left mouse key, release the left mouse key, that should work. And it's just left with the mouse position. That would be the input mouse position. Okay, this is the entire do button function implemented. Not actually that much. And to me, it looks very clean. You know what happens in every single state, and you can just have as many buttons as you want. You can do buttons left and right. Very easy. Now, the last thing we need to do, before we hook this up with the renderer, of course, we also need to gather the mouse information. And we also need to fix these errors here. Let me do that real quick. Now we are back in the Win32 platform CPP file. We are changing the platform layer. And so inside the platform window callback, we are fixing these buttons that we changed. Like we changed that to prefix key. And we need to now look at mouse events. We have what is called VM mouse. And one of those is mouse move. This one over here. Break. Whenever we move the mouse, what we want to do is we want to set the input dot mouse previous mouse position to the input dot mouse position. You know, we update the current one. Next, and then in the input dot mouse position, we assign to that, since it's a vector 2, we can read the positions. These are integers. We convert those to float here by using a macro from Windows. It's called get x underscore l param, like this. From the L parameter. This gives us the X coordinate, and then we do another one, which is float get Y L param from the L param. In order to use those two functions, you can see they are not declared. And also let me put a breakpoint here. Don't forget the breakpoint. We need to include what is called Windows X.h. And when I was coding this, I noticed that Windows is at the very top here. I don't want this because Windows by itself includes some stuff that game should not have access to. And so I'm going to move this down. Just include this here. This would be the platform. And then as you noticed, we now have no more errors. That's mouse move. That's all we need to do. And in order to get clicks, we need to define a case WM button down. This is the middle button down. Then we have the right button down and the left button down. Let's do LMR like this. And these are the mouse buttons. And for down, we also have up. So instead of down, we do up. We handle all of those together. In order to know what stage we are in, bool is down. And this is basically a copy from this, right? We are checking if the message is the same as WML button down, or the message is the same as WMR button down, or the message is the same as WM button down. Then we set is down to true. Otherwise, we set that to false. Let's just make that a bit cooler to look at, like this. Oh, and I forgot the semicolon. The next is the key ID. Then we need to find out. And for that, we need to check if message is the same as WML button down. Is it the left mouse button? Or is the message the same as WML button up? Then we want to use the key left mouse. Otherwise, we want to check if the message is the same as the WM button down, or the message is the same as the WM button up. Question mark. Then we want to use the key middle mouse. And if not, we want to use the key right button, right mouse. And that should format nicely. And all we do is input.keys on key ID. We increase the half transition count and we set is down to is down. And then we can do the same thing for the mouse click position that we did with the mouse position. We get the X and Y coordinates from the L param, and instead of mouse position, we do mouse click position. If that is something that we want to keep track of. And let me put this break here inside. I think I like that more. And this is everything about the mouse. If you like what I do, consider tuning into my Twitch. I stream at 10 AM Central Eastern Time, which is 1 AM Pacific Daytime. If you want to directly support me, you can do so via Patreon. This will give me more time to work on my game Cakes to D, and you will get reading access to the GitHub repository. Patreons will also be called out at the end of every video. Subscribing and leaving a like also helps a lot. Thank you very much for your support. So yeah, thank you to Michael Phillips, Felix F, and Meo the writer for your support. Additionally, pixel art I publish on itch.io will also be available for Patreons.